Okay, so this is a video tutorial on how to get started with saving sensor readings from an Arduino onto an SD card. So to get started, we're going to kind of go over some of the components that we have here. You're going to want to build this circuit with all of the components in your kit. But to kind of go over what we have an Arduino Nano right here hooked up to a push button. And that push button is set up in the standard configuration with a 10K resistor and is plugged over here to digital pin number 2. We also have a photoresistor, and as you can see, that photoresistor also has a 10K resistor and is running this brown wire to A0. That's an analog sensor that we're going to be pulling some light values from. And then finally, we have a LED, and that LED is hooked up to digital pin number 3. And the LED is here to kind of serve as a kind of confirmation that we are in fact getting values, because we're going to be writing kind of some sensor values to this SD card. But we want to make sure that, since we can't immediately see it writing to the SD card, that we'll have some sort of visual indicator that, that we're getting a signal. And so go ahead and study this diagram, and you can pause the video and build your circuit, and then we're going to start on some Arduino code to get everything up and running. Okay, so by now, hopefully you have your circuit all built, and we're going to be referencing this quite a bit as we're kind of developing our code. And so the first thing that we're going to be doing is let's go ahead and start with some of the basics. So we are going to call this our SD writer, and let's talk about some of those very simple components. So we had mentioned that we had a button, and that's hooked up to pin number 2. We had an LED hooked up to pin number 3, and we had that light sensor hooked up to a 0. So that's going to be pretty straightforward. But we've also got this SD card reader. So let's kind of talk through kind of how that's going to factor into our design. Well, there's going to be a couple of libraries that we need to include, and these are the ones that allow us to interface with the SD card reader. The first that we're going to be including is the SPI library. This is the communications protocol that the Arduino uses to talk to the SD card reader. The other library that we're going to include is the SD library. So again, this contains some simple commands that allow us to be able to read and write from the SD card. The last thing that we're going to need is some sort of file object that kind of keeps track of a file on the SD card. And so I'm going to just go ahead and call that data file, and it's of type file. Once we're in our setup, kind of per usual, nothing kind of extraordinary here, we're going to begin a serial connection. So we'll do serial begin 9600. We'll set the pin mode of our button to an input, because obviously it's an input, as well as the pin mode of our LED to an output. And we also need to kind of initialize our SD card. And so we're going to write a little function that'll do that for us. We're going to call that function Init Sd. And down here under our loop, let's go ahead and create that function and talk about what needs to go inside of that. So the first thing that we can do is we can put a little message here to us saying serial print ln, and we can say initializing the SD card. Then what we'll do is we'll say if, and we'll say if it not sd.begin, and the chip select on this is going to be 4 per how we plugged it in. And so if for some reason it can't begin, then we should send a message saying failed, so that we know that it was okay. And at that point, then we just need to return and quit out. However, if we are successful, then we can say done, meaning that we were able to actually connect to the SD card. So that's going to run right at the beginning of our setup, and just make sure that it's able to begin talking to the SD card. Okay. Now at this point, then, let's talk about what's in our loop. Now I think the way that we want this to work is we're just building a simple example of how you would kind of develop some comma-separated data that could be imported into a SQL database. And in this case, what we're going to say is when the button is pushed, it's going to take a sensor reading here, turn on the light to kind of let us know that it's successfully taken a reading, and then write that data to the SD card, kind of whatever the current value of that is. And we'll use the millis function to kind of keep track of the time, so we kind of roughly know at what time was the button pushed and the sensor, the light sensor read. So to do that, well, the first things we're going to do is just check to see has the button been pushed. So I'm just going to kind of create a raw input variable, just something to store the value of the button. So we'll say digital read button, and that's going to go get from the Arduino the current status of the button. Well, we know that if it's pushed, that it's going to be equal to 1. So if it's 1, well, what do we want to do? Well, we said the first thing that we want to do is actually turn on that little LED. And so if we say digital write LED high, that's going to go ahead and turn on the LED. And at this point then, we're going to need to kind of create some information that could be written to this data file. And the way that we're going to do that is with some strings. Now there's a couple of bits of information that we want to keep track of. I'm going to have one called now, and that's going to be kind of what is the current time that the button was pushed. Now if I call the millis function right here, I'm going to have a problem because millis is a number. It's not a string, and so Arduino is going to complain about that. But that's okay, because what I can do is I can actually wrap up the millis function in this string function, and it'll turn this number into a string, and we'll store it as now. So let's actually do the same thing with the light reading, and so we'll say string, and I'm just going to call this one bright, and I'm going to say, well, turn whatever is inside this function into a string, and in this case, I'm going to say analog read the light sensor and turn that into a string. And this may seem a little bit weird, but I'm also going to create a string for a comma because I want to comma separate these values. And so what I can do now is I can kind of create my final data string that I want to write to the SD card, and that's going to be now plus comma plus bright. And so in this particular case, I will now have some simple data that can be written. I want to add kind of one more thing here, and essentially that's going to be a little counter, so that every time it takes a reading, it kind of increments that counter. And so I'm going to add a counter variable up here and start it off at 0. And so down here, I'm going to say string count equals counter, and again we need to turn that into a string as well. And this will kind of serve as like our ID in our database. And so I'm going to add count here. And then on our way out, we're going to make sure that we increment counter so it goes up 1 each time. Okay, so now we've got our string. We're ready to kind of write that. And so we're going to actually create another function called write SD. And we're going to pass this data string that we kind of built up here to the thing. Now I have noticed one small issue here is that I need to add a comma here, so we have kind of count with the comma, now with a comma, and then bright. And so there's a comma between every kind of numerical value that we're sending here. And so we're going to write the data. We're going to delay for just a little bit, just to give it enough time to actually write that value, and not a whole lot, just 250 milliseconds. And then when we're done, we need to digital write our LED to low. So we're going to shut that LED off once everything is done here. Okay, so we said we were going to write this function, so let's go ahead and do that. And so I'm going to come here to the very bottom, and I'm going to say void write LED. And at this, or I'm sorry, not write LED, write SD. And at this point, we said, well, we need to kind of bring in some of that string data. So I'm going to bring in that string, and we'll call that incoming string data val. Okay. And so now the idea is kind of, well, what do we need to do? Well, so what we're going to do is we're going to kind of think back on that little data file that we made here, and let's actually do something with that. And so we're going to say that data file equals sd.open, and in this case, we're going to actually create a file on the SD card called data.txt. And we'll say that we want to write to that file. And so let's check to make sure that that was successful. So we can say if data file meaning that we were successfully able to kind of open up that file and write something to it. Let's again send ourselves a little message saying serial print ln, and we'll say writing to data.txt, and this is just a message for us that will let us know that something is happening. And let's go ahead and serial print that value. And again, this is just to show us what's going to be going on through the serial monitor. And at this point then, let's actually write it to the SD card. And the way that we can do that is we can say data file dot println, and let's print that value. Okay, and at this point then we can say data file dot close, which says close that up. We're done writing that value. And then once we're done with that, we'll send a message back to ourselves saying, you know what, this is all, done now. Okay, and so at that point, we're saying, yep, were you successful in doing that? If we weren't, we can say else, and here we can give ourselves a little message saying serial print line, and we can say that there was an error writing data. All right, and so that's all we really need to do here. So again, kind of pretty simple, writing to a data file. You kind of open it up, you print to it, and you close it. The rest of this is just messages to help us understand what's going on. So let's go ahead and save this. So we'll call this SD test. And let's go ahead and get that uploaded to our Arduino Nano. Okay, so we're uploading now. Okay, done uploading. So let's open up our serial monitor. So it says initializing done. Okay, so that's good. So that means we're actually getting something. And so I'm going to kind of push the button here. And here you can see that, it's, writing, entry 0. Our time is, 4,400 milliseconds, and the current light is 772. So I'm going to cover the light sensor a little bit and click it again. Okay, and this time you can see that the next thing that got written was entry 1, so it did increment by 1. It's now 19 seconds, and you can see it's actually a little bit darker. It's 422. Okay, I'm going to hold it up to a light, nice and bright. And again, we can see that this is incrementing up little bit by little bit. Okay, so I'm going to kind of push it a few more times just to get some data. And I'm going to close this down and unplug the Arduino. And at this point then, just to kind of verify what I have going on, I'm going to pop out the SD card, and then I'm going to test to see if I was able to actually get some good data. Now, in order to see what's on the data, these are SD mini cards. And so I have a few adapters that you are welcome to borrow. And so you can put the SD card inside of them and plug them into your computer. So I'm going to do that right now. And let's actually see if we can recover that data from the SD card. So I can see that it pops up here. And I can see I do, in fact, have a data.txt file. And so if I open that up, sure enough, I've got a comma-separated file here. And so if my SQL table was set up to have kind of an ID and a sensor time and a light value, again, depending on your entity relationship diagram, that could be different based on what you're doing. But as long as these are in the same order, you're going to be able to import these into your MySQL tables. So again, just make sure that whatever order you're kind of putting the information in the Arduino matches up the expected order that you have in your SQL tables, and you can refer to your ERDs for that. And as long as that's in good shape, then you'll be able to capture that data. And that's it.